Good afternoon, everyone. Hello, my name is Dr. Emily Duggan. We are so pleased that you can join us all today for the second lecture in the volume 4 of our 12-week No Neuropsychology didactic series that brings to you lectures from experts in the field covering different topics each week. The series was created by trainees and early career neuropsychologists to provide free, high-quality didactic opportunities. We would like to thank our sponsors and their financial support for the series. And before we start, here are the disclaimers for this series. This training is not meant to replace formal education in neuropsychology, and the views of the speakers are their own. Questions can be submitted via the Q&A box on the lower portion of your screen, and a recording of today's lecture will be provided on our website later this week. Now, it's my pleasure to introduce Dr. Casey Dieters. Dr. Dieters is a postdoctoral fellow at the University of California, San Francisco in the Department of Neurosciences. She completed her first postdoc at Stanford University between 2017 and 2021. After completing her PhD in medical neuroscience at the Indiana University School of Medicine in 2017. Dr. Dieters' research focus is on ethnic and racial disparities in cognitive aging and Alzheimer's disease in older adults, primarily from the Black community. Dr. Dieters is very passionate about diversity, equity, and inclusion, and currently serves on the advisory board for the Resource Center for Minority Aging Research, or the RCMAR. Welcome so much. Thank you for joining us, Dr. Dieters, and I'll let you take it away.
Hi, thank you so much. I'm so happy to be here, and thank you for the wonderful introduction, Emily, greatly appreciated. I'd like to give the disclaimer that I am a neuroscientist by training, but I am hoping to break into the clinical neuropsychology world. I'm very interested in cognitive measures and cognitive tests, so I'd like to give that disclaimer before my talk because I'm still learning a lot about your world and about neuropsychological assessments. Let's see, so I'm going to be talking about disparities in AD risk factors for the Black community. And I'm also going to be talking about these risk factors in a cognitively normal population as well. And of course, follow me on Twitter if you're available. So I am super happy that I was able to follow Dr. Jennifer Manley last week. As always, every single talk of hers, it was amazing, super informative. So I was able to kind of tailor mine to kind of follow all of the risk factors that she already talked about. And one of the things that her and other leaders in the field always make a point to state, and that is research thus far has been centered in whiteness, whether it be clinical or cohort studies. And so considering that most of this research is focused on non-Hispanic white individuals, how can we fully understand risk factors if we don't look in a diverse population? This is a great figure from Elizabeth Rose Maeda, who's at UCLA, who used data from Kaiser Permanente to look at across the different ethnic racial groups to look at Alzheimer's disease risk or dementia risk in the population of Northern California. And we can see that those who self-identify as Black or African American actually have an incidence rate of AD that is twice that of the white population, which is shown here in the coral or pinkish color. Now, there are several markers of Alzheimer's disease, and we can use this to identify its progression. So some risk factors, I'm sure everyone's aware of: age, family history, sex, lifestyle, genetics, APOE4 being the largest genetic risk factor for Alzheimer's disease. And we can use biological markers or biomarkers such as measures of amyloid and tau from CSF, PET, now plasma markers, which is really exciting work, MR imaging, and of course, cognitive measures. So I'm really interested in, are AD risk factors the same in the Black community? So in short, they're not all the same. So an example, there was a great review by this, I'm probably going to mispronounce that, but Degani, that looked at genetic risk factors across various ethnic and racial groups, and just drawing your attention to the white population, which is in brown, and the Black population, which is in red. You can see, like, for example, APOE seems to be a larger risk factor for the white population than for the Black population. And some other ones, including ABCA7, which has been emerging, which appears to be a potential larger genetic risk factor for AD risk in the Black population as opposed to the white population. I'm not going to go too much into this because Dr. Manley talked about this in last week's talk, but protein biomarkers do not appear to be the same for Black individuals. And she followed that up with some great discussion as to why we may be seeing this, but there has been research to show that CSF tau is lower in Black participants relative to white participants. But CSF amyloid, it's been a little bit more conflicting results. I've seen some studies say that it's not different and some studies say that it is. And of course, postmortem neuropathology results. Black participants, which is shown here on the left panel, present with much more neuropathological comorbidities in the brain relative to white participants. So for example, the AD brain has tau and amyloid plaques. So you can see that the white participants have a much larger ratio of this pure AD pathological insults in the brain relative to Black participants. And it seems that Black participants actually have a larger Lewy body and infarcts. However, one thing, again, that Dr. Manley also presented on last week is that the rate of cognitive decline actually seems to be the same between Black and white participants, which goes to show a few important facts. First, just to orient you to this figure, which used data from the Chicago Healthy Aging Project. The global cognitive score is here on the y-axis, and age is on the x-axis. And so if we just look cross-sectionally using neuropsychological assessments, we can see that no matter what age you look at, it appears that Black people perform worse than white people. However, when we look longitudinally, we see that the slope change is not different between Black and white participants, no matter what age we start at. And so this goes to show the importance of the two things. First, that there's obviously, which we're all aware of at this point, I'm sure, that there is racial bias in our current neuropsychological assessment testing, but also the importance of longitudinal data when we are studying risk factors for dementia or cognitive aging. And I want to give a little background on genetic admixture. So I think this has been increasingly being used in research. And so genetic admixture, genetic information from two or more populations, I just used this example to kind of show, which I'm sure we're all familiar with, is that, of course, we have two populations, and after many generations, our chromosomes have this genetically admixed DNA. So if we look at somebody who might be from West Africa versus somebody who's from a European population, and we get to this certain SNP, say this is SNP, I don't know, RS number 5, 6, 7, 8, 12. Somebody from West Africa may have this SNP at this location versus somebody who's a European may have a G allele at a specific location. So somebody would call these an ancestry informative marker because it's only present in one ancestry group and not the other. And so then we can use this information then to calculate somebody who has admixed genetic DNA, and we can calculate what is their West African ancestry percentage or what is their European ancestry. So we can do this for all the little groups wherever we have genetic data from. So, of course, due to the transatlantic slave trade, people in the US, if you're a US born Black or African American, you have highly genetically admixed DNA with European and African ancestry. So this is an example, and this has been shown repeatedly in several studies with several different cohorts that, again, this is specific to US born people who identify as Black or African American that have been here for generations. Your percentage of African ancestry ranges from about 30% up to about 96%. However, there are some very important things that I want to relate to this audience. And race is a social construct that is typically based on visible characteristics, and it's mainly used in the United States. I do not believe that race is biological. So I'll say that again, race is not biological. I would like to get away from that. However, unfortunately, as we know, our past research, race has been used as a proxy for a biological measures. So I think one of the main questions that now that we have these ancestry informative markers is how can we actually explain differences between biology and life course risk factors? And again, to kind of follow up with what Dr. Manley discussed in last week, she brought up the paper by Dr. Jorge, excuse my pronunciation, Guerra, who looked at admixture in the Cuban population. And what was really interesting about this study and really great is that all of these participants came from a similar social, socioeconomic status background. So we can see that this African admixture, so he used a genetic ancestry measure using, I think, about 60 AIMs or ancestry informative markers. And we can see that if you identified as white, you mainly are white. You have very low African ancestry. However, if you're Black, you can see the blue dots, which represent Black participants in Cuban. They have this range of African ancestry, as we discussed previously. It looks like here they have kind of all over, but in general, it's about 20% up to maybe about 85, 86%. And just to kind of show that since these do come from a similar socioeconomic background, he actually showed that no matter what demographic variables you control for, they actually did not have any genetic admixture for African ancestry, did not contribute to differing cognitive scores. So I'm going to give an example of, while I do not think race is biological, we have these ancestry informative markers. We do know there are very, very, very few genetic differences across different racial groups. And why would that be important to still study? And this is a recent paper from earlier this year that I did in collaboration with Dr. Lisa Barnes at Rush University, looking at the TOM40 APOE haplotypes and its effect on cognitive decline. So for this study, I used 3 different cohorts. That would be the religious order study, which is nuns, priests, and brothers from the US, the Rush Memory and Aging Project, which is from the greater Illinois area, and the Minority Aging Research Study, or MARS, which are Black individuals from the Chicago and surrounding suburbs. So TOM40, I'm sure everyone's familiar with APOE gene or apolipoprotein E, but TOM40 is the translocase of the outer mitochondrial membrane 40 gene. It's actually in linkage disequilibrium with the APOE gene, and it codes for a channel-forming subunit required for protein to import into the mitochondria. It actually codes for these intronic poly-T repeats. So at this specific location in the genome, you'll just have T's like T, 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 T. And this poly-T repeat varies in length by individual and race and ethnicity. So if we're looking at this poly-T repeat length in the Rush cohort for both white and Black individuals, it looks like it's the same, right? You have these number of T's from about 13 up to about 40. In the Black individuals, you have very few that go up to 49. So you would not think that there's any type of difference. However, once we map once we map TOM40 onto APOE background, we start to see some differences. So first, we see that if you're white and an APOE3 carrier, you have T repeats less than 20 and greater than 30. Or if you're an E4 carrier, it's between 20 and 30. So we call these short, long, and very long, or as I'll quote them on the future slides, just SL and very VL. And then in the Black population is where we start to see some of this variation. In the APOE3 Black carriers, we see that they have mainly short and very long, with only one person present with the long variant. However, if we look at the E4 carriers, we look at the Black versus the white, it's completely different. The Black E4 carriers actually have poly-T repeats that span the entire range length that is present between 13 up to 40. So I was very interested, what could this potential difference mean as it relates to cognitive decline? And before I get into that, I think you may be wondering, why where could this possibly come from, right? Where would this diversity in poly-T alleles come from in the Black individuals? And the answer is admixture. So Alan Roses actually sequenced these for a white population, US born, African American population, and Yoruban, which is an ethnic group in Nigeria. So what you can see is if you're E4 and white, you have that long, as I showed on the previous slide, between 20 and 30. And if you're Yoruban, you have all of these on short, long, and very long. So if you're from the United States and Black, and you have this genetic admixture of African and European ancestry, you can end up with a range of poly-T repeats on your E4 allele. So how does this impact cognitive decline? I'll kind of go through this slide relatively fast because we found no difference here. So what we decided to do is look at if the short allele was associated with cognitive decline in E3 carriers, E3 homozygotes. So we have memory on the y-axis and time on the x-axis. And if you're Black, it's the solid line, solid red line. And if you're, just the red line. And if you are white, it is the blue line. And if you are the risk group, it's the solid line here. So what we can see is that as expected, Black participants have this lower interest at that baseline of cognitive measures. But when we looked at the rate of decline for these short E3 Black carriers versus the short E3 white carriers, we actually see there was no change in slope difference between these two. But again, I wouldn't necessarily have expected that, considering they show a very similar pattern. What's interesting is this E4 group in which we see this great diversity from the poly-T repeats. So again, memory is on the y-axis, while time is on the x-axis. Because there is no poly-T diversity, the white E4 carriers is just one group. It is just, so they're the Black line, which I'll show in a second. And then we have these three genotypic groups for the Black E4 carriers. And that is the short, which is red, the one short allele, which is blue, or having no short alleles, which is gold. And we would hypothesize that not having any short in this group was associated with an increased risk of cognitive decline. So we can see a few things, and that is, first, we see that if you are Black and do not have a short allele, you do have a significantly faster rate of cognitive decline relative to Black people who do carry a short allele. And when we look at this in comparison to the white people from Rush, we see that, of course, they have this higher cognitive intercept at baseline. However, if we look at the not short, which is this white group, versus the not short Black group, there's actually not a significantly different rate in change for the slope. However, there is a significant difference between Black people who carry an S versus the white group, which suggests that there may be this protective group of Black E4 carriers. And then next, I wanted to talk about another biomarker, which is amyloid and APOE. This is when I was a postdoc at Stanford with Dr. Beth Mormino. And for this study, we used a clinical cohort study, which is the anti-amyloid and asymptomatic AD study, or the A4 study. So this is a secondary prevention trial in cognitively normal individuals, and they are given an anti-amyloid drug in order, and it will be followed longitudinally in order to see if this caused any prevention in cognitive performance over time. So amyloid PET in clinically normal older cohorts. About 30% of cognitively normal adults that are over the age of 70 are actually amyloid positive. So we consider this preclinical Alzheimer's disease, where there's AD pathology present, but there's no clinical symptoms. So about 30% of the population, which is quite a bit actually. And Amyloid positive, cognitively normal older adults, they're at greater risk of future memory decline, as shown here from some of Beth's work, which this red line here shows people that are E4 positive and have high amyloid beta across a global memory measure, MMSE. However, it's unclear if these findings also translate to other populations, such as the Black community. So the goal of this study was to determine the effect of white and Black participants on amyloid and whether these effects were influenced by APOE or African ancestry. So first and foremost, let me just orient you to this graph, and that is that we are just doing the basic, and that's looking, are amyloid levels different between Black and white participants? So we chose to look at continuous amyloid SUVR measures here on the y-axis, and we chose to look at racial groups. Black is red and white is blue, broken apart by APOE genotype. So E3, 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 E4, and E4, E4. So overall, without anything, just by looking, you can see that all the Black participants across the groups have lower amyloid in each of these APOE genotypes relative to the white participants. However, this effect was only significant in the E4 carriers, suggesting that E4 was actually driving lower amyloid in these participants, which is very interesting because if amyloid is such a large risk factor, why are we actually seeing lower amyloid in people who have E4, which is supposed to be a larger risk factor? It seems that maybe there might be something else contributing to amyloid levels in the Black population. And while I am showing the full data set here and with continuous amyloid measures, we did see the exact same, almost the we use dichotomous amyloid or in matched groups of Black to white. Then we wanted to determine if African ancestry was associated with amyloid. So there are about 118 Black participants in A4 that had genetic measures we were able to calculate ancestry on. As I mentioned previously, African ancestry exists on a continuum for US-born Black people. So we have this continuous measure of African ancestry from about 30 to 80% in this cohort here. And so what we see is that people with higher African ancestry actually have lower measures of amyloid. Again, this kind of goes in line with the previous finding of lower amyloid than if we expect this to be bad, but it's not as large of a risk factor in this group, then what is driving? So amyloid SUVR on the y-axis here, by the way, is these are residuals after age, sex, education, and APOE2 and APOE4. And yes, and this percentage of African ancestry, the effect we see here is actually independent of APOE. And Dr. Manley was so kind in the last seminar as well to share my supplemental image that showed the people that were excluded from the study based on cognitive measures. So while about 4,400 people completed PET, about 2,200 had no amyloid PET, which Dr. Mormino and I determined to have failed screen. And the reasons you're potentially failed screen are medical reasons, having a CDR greater than 0, MMSE greater than 25, or logical memory between 6 and 18. So that led us to wonder if there's any selection bias within the A4 that could have been driving the results that we saw with either African ancestry or amyloid. First, we saw that Black people were more likely to screen fail relative to the white participants. About 55% of the Black participants screen failed relative to the white participants. And why did that happen? Probably doesn't come as a shock, but it was due to low cognitive test scores. So Black individuals were more likely to screen fail from low cognitive test scores and less likely to screen from high cognitive test scores. In fact, white people were more likely to screen fail because they had too high of cognitive test scores. So this really begs a few discussion points, and that is, could the A4 study have actually been selecting for a more cognitively resistant, a more resistant group to cognitive deficits over time? So just to summarize everything I've talked about so far, so we know that APOE4 has an effect on cognitive decline in both Black and white participants, but the E4 doesn't seem to be as large a risk in the Black population relative to the white. But there is this group of APOE4 carriers that if you don't carry the short allele and you're TOM40, you actually have this increased rate, a faster rate of cognitive decline over time. We show that Black participants in A4 had lower amyloid relative to white, and that this lower amyloid was due to high African ancestry and APOE4 carriers. So this lower effect of APOE4 on AD risk may be mediated by pathways related to amyloid accumulation. And Black participants were more likely to screen fail relative to white participants. So again, is there actually more of a selection bias creating this more resilient Black cohort? And it's going to be really hard to continue to identify this true AD risk profile for Black individuals if we continue to use neuropsychological tools that were developed and validated on solely white participants. One thing I haven't talked about that I am super interested in, and I hope to one day get a faculty job and lead an amazing lab focusing on both neuroscience, genetics imaging, and bringing in is, looking at life course factors. So Dr. Carl Hill put out this NIA Health Disparities Research Framework to try to incorporate environmental, sociocultural, behavioral, and biological factors when we're looking at things like disease risk or cognitive aging. And an example of this I love from Dr. Lamar is looking at lived experiences that have psychological effects. And so that is people who were in segregated or desegregated schools. So they looked at participants that were in the Northeast or Midwest in desegregated or segregated, and then people in the South that were in desegregated or segregated schools. And although not significant, we do see that, or they did see this trend that people that were in desegregated schools actually had lower cognitive performance, suggesting that the stress of being in desegregated schools at the time actually has lifelong lasting implications on cognitive health. So these lived experiences might have psychological effects, which might have biological underpinnings, and for example, these stress pathways that I just mentioned. And another thing that I'm interested in is looking at sex differences in Black individuals. There is really not a lot of research at all that are focused on Black men versus Black women. And part of that is because there is a larger percentage of Black women that actually volunteer for cohort or clinical studies. I think it's usually at a rate of like 70% Black women relative to 30% Black men. And so Dr. Justina Avila, she actually showed that we can see some differences between white, Black, and Hispanic men and women, mainly at baseline, but we have there's fewer differences in cognition if we look over time, which is this cognitive slope. And just to reiterate what Dr. Manley shared last time and others like Dr. Lisa Barnes, I think it's super important that we just keep this on the top of our mind every time we're doing our research. And that is that to remember that we have to investigate risk factors that have been validated in the white community across other populations. I think it's super important, and so sure everyone here in this group knows that we examine cultural biases across neuropsychological tests, that we collect and analyze data related to the lived experience or over the life course. I think it's super, super important to look at recruitment bias. To my knowledge, there's been a lot of studies that I've gone to try to use some data for that they don't report anybody that was excluded. So it's really, really hard to actually determine where any of this recruitment bias or selection bias actually exists. Even right now with the A4 study that I shared, it wasn't a measure that was given. We kind of had to extrapolate that information by looking at people that did not have a amyloid PET scan. And of course, increasing historically underrepresented individuals in all aspects of research because diversity matters. And with that, I will just thank everyone at my lab at UC San Diego, who I've only met in person a few times thanks to the pandemic. Just been working from home. I shared almost all of this work was done with while I was at Stanford with Dr. Beth Momino and with our collaboration with Dr. Lisa Barnes at Rush. And that's all I have.
Thank you so much, Dr. Dieters. I am just so fascinated by your work, and I feel like I could ask you questions all day about it. We did get a couple questions in the chat. So back when you were kind of describing, when you started phasing into describing the results early in your presentation, someone wanted to just clarify and make sure that they were understand that when comparing Black and white populations, that both groups may have had different levels of global cognition, with Black groups being more susceptible to AD, but there was no rate of change in cognitive decline for either group. They wanted to clarify that.
Correct. Yeah. So a few studies have shown that while there's a difference in cognition at baseline, the intercept is different, but once you start to track cognition over time, it doesn't appear that there's actually a difference in rate of cognitive decline over time.
Got it. Thank you for clarifying that. A second question relates to, it's hard for us to see when Black and African American individuals are at higher risk for getting Alzheimer's disease. And I'm glad that you were kind of touching on the social determinants of health and environmental factors. And I agree that this is perfect timing after Dr. Manley's talk too. From just your perspective and, where you're coming from, your scientific background, this person is wondering, how can we begin to reduce this health disparity within the Black community? And that's a huge question, but I guess, just from your kind of translational thoughts on the research, what are your thoughts along those lines?
Yeah, that's a really, really big question. And so that is something that I'm definitely working toward. I would definitely direct them to groups like Dr. John Manley at Columbia, Dr. Lisa Barnes at Rush. There's Dr. Amy Kind and Carrie Gleason in Wisconsin. These are all people who have been leading their own research for decades now and can probably have a great wealth of work on that. But I think kind of what I alluded to earlier in trying to actually start addressing disparities is actually focusing on the life course factors, because as some of the evidence that I showed earlier from Dr. Ibre Guerra, sorry, again. But he showed when you have people from a similar socioeconomic background, yet they have this genetic admixture here, even though they identify as one race, you can actually see that there is really no effect on cognition in this group. Or cognitive function in this group. So it kind of actually suggests to, the importance of social factors, life force factors, socioeconomic, whichever type of, name you want to name it, how important that probably is here in America, contributing to these different cognitive pathways.
I'm so glad that you brought that up, because I really personally, I have a lot of passion for cultural neuropsychology, and I've been thinking a lot about, what are different ways for us to really start pulling these ideas apart and understanding the risks better. And so this idea of genetic admixture and looking at that within samples, I think is amazing. Do you think that that is something that we would benefit from consistently including in studies? I don't know a lot about it. Is it a feasible thing? Does it cost a ton of money? Or are we going to just see the same thing over and over again, that the genetic admixture is not the thing that's going to be pinpointing that? It's really going to be the other social determinants that are driving the differences.
Yeah, so both in my perspective. So I do not think race is biological. However, I do think that there, as I showed from the APOE and Tom Forty paper, there are specific ancestry informing markers that I do think are going to be important in contributing, to cognitive function or AD risk. So I think it's important to still look at it. I really am really want to get across that I do not think it should be a proxy for race. I do not think that we should use genetic ancestry as a proxy for race at all. It is just to look at potential genetic predictors for Alzheimer's disease risk or cognitive decline. And I would never want to just remove people determining, self-identifying their race and like, let's just look at ancestry. I don't think that should be the way. It's just purely to look at genetic risk. And part of that comes from, my own background. I'm Black and white. And so when I got into AD research, and I just got into disparities research 3 years ago, so I'm still relatively new, I'm still learning a lot. I'm still gaining, trying to become an expert in this field. And so when I saw that E4 was such this large risk factor for white people, but not as large in Black people, that really got me thinking about, like, what about people like me? So the census actually this year had like a 276% increase from 10 years ago for people who are identified as multiracial. So when you think about the way in which the US population is going, when we're 60 in our 60s, which is like 30 years away, about 30 years away, it's going to be a multiracial population. It's not going to be just as clear as non-Hispanic white individuals. So I think it's super important to just really focus on a diverse population, because the way this country is going is really diverse. So second part of the social. And yeah, I do think that, and I think that they're separate, but should be combined in the sense that, socioeconomic, social life course factors, they're all going to be super important. I think it's really interesting super important to actually focus on like within groups. So I'm starting to build my research toward just focusing on the Black cohort, not comparing them to white people, right? Because let's start looking at the diversity within our group. How much does XYZ, genetics, socioeconomic, whatever, impact cognition or disease risk? So I think they're both important and going to have to interplay. But I'm still building up my own expertise and thoughts on that as well. So.
Absolutely, it's an exciting area with a lot of potential. Someone asks, would it be possible to consider an approach with structural equation modeling to clarify if only ancestral genetic or the interaction of the other latent variables is responsible for the disparities in cognition risk for AD between Black and white populations?
Yes, I do think so. I don't really know how else to go more in depth than that, but yeah, absolutely. I think that we're still building up our cohorts, getting information. While we have thousands and thousands and thousands of these data for the white populations, I think we're still building our cohorts. And we have a few really, really great ones, again, such as Dr. Mann just talked about last week with her cohort. And then again, the ones that I talked about, they've done a really good job of not just collecting the standard measures of cognition and, blood or CSF or imaging, right? They've gone beyond that and, asked about different life course factors. So I think making sure that continuing to build the cohorts and get these type of information in order to fully analyze the data set, these cohorts, and hopefully be able to merge them for power, I think will be great in the future. So yeah, definitely agree.
Yeah. Thank you for going through. These are, very philosophical questions and practical questions.
Yeah.
And I think this comes from a lot of people's, excitement, but also awareness of wanting to change the way that they're thinking about these constructs and how to practically move forward. So one attendee asked about maybe just if you could elaborate a little bit, and I think you've kind of touched on this, but I'll kind of put it out there and we can kind of navigate it together here. You can elaborate on how your research differs, and this type of research differs from race being biological when we're focusing on those differences. I think it's kind of wrapping people's heads around genetics versus how we're going to kind of imagine what these things are. And how do we kind of then communicate that to other people and kind of help adjust the way that they're thinking about these constructs of race, groups, or diversity differences?
Yeah, that's definitely a big question. How do we change people's mind? I think it's very hard, right? Once people have their mind made up on certain things, it's very, very hard to change that. So all I can say is what I can start doing now and hope to build to in the future, because I don't want to I don't feel comfortable answering the question about how can I change people's minds, on that aspect. But I can say, I think, adding diversity into science is super important. Right now, or not right now, but, in general, a lot of times, science itself is really white, right? It's not really minoritized. So there are white people making decisions, I feel like, for a large part of a lot of these studies. So I think adding diverse perspectives and diversity into a group, I think will just raise awareness for a lot of these different factors. And just continued work, I think continuing to work and publishing and showing people the results. And I think effective science communication also, I think, is going to be super important as well. And I think that the diversity initiatives that have been going on from the NIH have been really great as well. I'm in full support of those. And trying to reach as many people so that way they realize that, hey, the NIH, the government, this is important. We need to start paying attention to this. And I hope that a combination of all of those will raise awareness. I feel like that's as far as I'm going to go with that.
I think that's an incredibly thoughtful answer. I agree. It's like, whoa, man, I'm having to do here. Yeah. I love also that you presented the NIA Health Disparities Framework. And I think it's nice to see kind of at the institutional level, providing language for people in ways to kind of conceptualize things so that they can really rely on that language to help guide what they're doing in those frameworks as well.
Definitely. And it's a great and succinct paper too. It's not like, it's dozens of pages long. So it's a great resource for sure.
Absolutely. Well, I think you have a lot of buy-in because we're getting questions about, are you aware of efforts to kind of change some neuropsychological tests to become more culturally sensitive at that kind of institutional or, like test manufacturer level. And I think some people are very excited to be involved in this.
Yeah, so again, I'm really new to the being into this neuropsychological world. So to my knowledge, yes, there are groups working on trying to create less culturally biased tests. I can only imagine how many groups are actually working on it. However, I've heard that I believe one of the major challenges is getting people in, right? You have to have a certain number of people in order to validate these tests. So I think not only creating the test, but validating, it's going to take time. But I do believe that there are groups working on it. I'm just working right now on trying to understand the tests we have now. So I can't answer that question too in depth.
Sure. With that in mind, I was just thinking about kind of the psychometric side of things. And when you were first talking about the admixture and the short and the long and the very long T repeats, at first I was like, oh, I wonder if she's going to do that in a categorical variable or a continuous variable. And so then I saw that you categorized them. Is that just because it's hard to kind of get enough people and kind of have the data analysis, or do you think there's any use for at a population genetics level, if we could continuously analyze that data and then use that in relation to the other types of cognitive or whatever physiological markers?
So I think I'm a little confused in the question. Are you asking if we could use the poly T repeats as a continuous measure or as opposed to the dichotomous?
Yeah.
Yes, you could. I think the reason why it's dichotomous is because that's how it maps onto the APOE background. I was really just trying to capture that certain groups between white and black on the E4 or the E3 allele map to that. So that's why they were categorized as opposed to me using them as continuous. At least that was my thought process at the time. So
got it. It makes me think of the Huntington's research where you have kind of, certain shorter amounts or fewer abnormalities, can change the age of expression of the disease versus if you have a stronger number of abnormalities, then it would come earlier on. So it's very interesting. All right. Well, I think I will stop grilling you with questions. This is a phenomenal talk, and
Thank you.
clearly your career is going in many exciting places, and we are so thankful to have you here for your presentation today.
Thank you everyone so much.
Thank you. Next Monday, we will have a talk by Dr. Adam Gersenecker on cognitive, functional, and psychiatric features of progressive supranuclear palsy, which sounds like a really exciting talk, and I hope everyone joins us. It will be at 11 a.m. Pacific, 2 p.m. Eastern. Thanks so much, everybody.